When you look at these two graphs, how are they related? You can see they have the same kind of curve, but you probably will quickly notice that the x and y scales are switched. In this sine graph here, the x-axis represents the angles and the y-axis represents the sine value, the trig value for sine, opposite over hypotenuse. In this graph, the x-axis represents the trig values and the y-axis represents the angle. These two functions are inverses of each other. And this is how we write them. Here we have y equals sine of x, where x equals the angle and y equals the trig value. For this graph, we have y equals inverse sine of x. And you may have recognized that notation when we did inverse functions with a little -1. We had f inverse of x, now we have sine inverse of x. And in this case, x is equal to the trig value and y is equal to the angle. So that's the difference between a function and its inverse, is that the input and the output switch places. Now you'll notice here, we can pick out a few points. Let's take a look at sine of 30. Sine of 30 would be, there'd be 30 degrees right here. And when we go up to this point, we see that sine of 30 is equal to 0.5. Now if we go to the other graph, we should go to 0.5, right there, 0.5 on the x-axis, and find that inverse sine of 0.5 is 30 degrees. Now if we go to sine of -30, which would be right here, and go down on the graph, we see that we are at -0.5. And if we go to -0.5 on the x-axis of the inverse graph and go to the graph, we see that we are at -30, because this would be -30, -60, -90. However, there's a problem here, because -1/2 on the inverse graph also gives me an angle here at 210, and another angle at 330, and another angle at -150. And 0.5 gives me an angle at 30, but it also gives me an angle at 150, and an angle at -210, and an angle at -330. So how do I know which angle is the angle that will come out if I do this on the calculator? So let's double check these two. So going to the calculator, we see sine of 30 is 1/2 or 0.5. Inverse sine of sine of -30 is -1/2. To do inverse sine, we go to the same trig button that we do for the others, and we find inverse sine here. So let's do inverse sine of 1/2. Inverse sine of 1/2 is 30, and inverse sine of -1/2 or -0.5, I could have just done 0.5 too, is -30. Okay, so far so good. That looks good. But what happens if we do something with some different angles? Okay, so let's look at this. Sine of 330. So if we go to 330 on our sine graph, we see right here, we see that sine of 330 is -1/2 or -0.5. And if we do inverse sine of -0.5, well, we just did that. If we do inverse sine of -0.5, the calculator isn't going to give me two different angle answers. It's only going to give me one answer because it is a function. So this is -0.5 as well. I'm sorry, this is still -30. I don't get 330. I get -30. I just did it on my calculator. There's no way I get two different answers. So that means if I go up and look here at my graph, if I go to -0.5, I know that 330 is not a possible answer. I can't get 330. That's not included in the function. Now if I go to sine of 150 right here, that is a +1/2 or +0.5. But if I do inverse sine of 0.5, do I get 150? No, I already did it. I get 30. So this tells me that for 0.5, 150 is not a possible solution. If I do sine of 210, I go to 210 here on my graph, I get -0.5. But if I do inverse sine of negative 0.5, do I get 210? No, I just did it on my calculator. You can try it again. You get negative 30. So that means negative 210, where am I? Or sorry, positive 210 right here is not included in the graph. It turns out that I'm very limited in the angles I can get. If I do inverse functions, I can only get one possible y value for every x value because that's the definition of a function. So how do I know which section of the graph that I use for sine? Okay, so let's. It turns out that I only can use one section of the graph for each trig value. All right, so for the positive trig values, I'm always going to get an angle from 0 to 90. And for a negative trig value, I'm always going to get an angle from 0 to negative 90. This is the entire inverse trig function. Okay, just this section of the graph from here to here. The rest of the graph is not included, because if it were included, it would not be a function. Now we're going to go in the next section, we'll talk more about what a principal angle is and how that relates to the sine graph.